All right, let's dive into the secret language of matter, chemical reactions. These are the invisible, powerful transformations happening all around us, all the time. I mean, they're what cook our food, power our bodies, they literally shape our entire world. So let's get right into it.
So to kick things off, I've got a question for you. What could a burning match possibly have in common with one of those fizzy antacid tablets you drop in water? I mean, on the surface, they seem like total opposites, right? But believe it or not, they share a fundamental secret. Any ideas?
Okay, the answer? They're both prime examples of a chemical reaction. And really, all a chemical reaction is a process where matter changes into a brand new substance or maybe even a few new substances. The original stuff is literally gone and something completely different is left in its place.
You know, every single reaction follows the same basic script. You start with your ingredients, which chemists call reactants. In this example, that's nitrogen and oxygen gas. Then, once they do their thing, they transform into totally new substances we call products. Here, that's nitrogen monoxide. The amazing part is, the atoms themselves don't disappear. They just kind of shuffle around and find new partners.
Okay, so we can't actually see tiny atoms rearranging themselves, right? So how in the world do we know a reaction is even happening? Well, this is where it gets fun. It's time to put on our chemical detective hats, because these reactions, they always leave clues behind.
We're going to go over the top 3 telltale signs to look for. And trust me, once you know what to look for, you'll start seeing chemical reactions happening everywhere.
Clue number 1, a change of color. This is one of the biggest, most obvious giveaways. If something just spontaneously changes color, that's a massive hint that a new substance has been created. Take a look here. When you heat up this blue copper nitrate, it turns completely black. That's not just a color change, that's a whole new material, copper oxide, being born.
All right, clue number 2, bubbles. Or, as a chemist would say, the evolution of a gas. Remember that antacid tablet from the beginning? All that fizzing and bubbling? That's carbon dioxide gas being created and escaping into the air. It's a classic, surefire sign that a transformation is underway.
And for our third clue, we have something that honestly looks a little bit like magic. It's called the formation of a precipitate. This happens when you mix two totally clear liquids and suddenly, poof, a solid material appears out of nowhere and sinks to the bottom. It's not magic, of course, it's just a brand new, solid product being created right there on the spot.
Okay, so now we're official chemical detectives. We know how to spot a reaction. The next question is, how do they actually work? Well, it turns out most reactions aren't totally random. They follow a few predictable patterns. You can think of them like plays in a playbook, or maybe even different dance moves.
First up, we have the combination reaction. You might also hear this called a synthesis reaction. The idea here is super simple. You take two or more things, let's call them A and B, and they react to form one single new compound, AB. It's all about two becoming one. This is a fundamental way we build all sorts of stuff, from plastics to medicines.
And the most famous example of this? The creation of water. You take two separate gases, hydrogen and oxygen, they combine, and bam, you get a totally new liquid substance. Two reactants form one product. That's synthesis in a nutshell.
Our next move is decomposition, and it's, you guessed it, the exact opposite of synthesis. Here, we start with one big compound, and it breaks down into two or more simpler things. It's one thing splitting apart into many. And this is super useful. It's used for everything from refining metals to making the airbag in your car inflate instantly.
A great real-world example is what happens when you heat limestone, which is just calcium carbonate. That single solid compound literally breaks apart into two totally different substances: calcium oxide, another solid, and carbon dioxide gas. See, it's decomposing.
Okay, for our third play, things get a little more dynamic. This is the displacement reaction. The best way to think about this is like a dance partner swap. Imagine you have a couple dancing, BC. Then a new dancer, A, comes along and cuts in, stealing B's partner. A and C are now a new couple, AC, and poor B is left all alone.
So let's look at a real example. If we drop some solid magnesium into a blue solution of copper sulfate, the magnesium is, well, it's the more aggressive dancer. It swoops in, displaces the copper, and takes its place, forming magnesium sulfate. The copper gets kicked out all by itself. A classic single swap.
And that brings us to our final play, double decomposition. Now, if the last one was a single swap, this one is a full-on partner exchange.
You have two couples, A and B and C and D. They come together and they completely swap partners. So now you've got two brand new couples, AD and CB.
For instance, if you mix together silver nitrate and potassium chloride, they don't just stay as they are. Oh no, the silver decides it likes the chloride better, and the potassium pairs up with the nitrate. Everybody swaps partners, and we end up with two completely new compounds. Simple as that.
So let's just quickly run through those 4 plays again, because this little summary makes it super clear. Combination, 2 become 1. Decomposition, 1 splits into 2. Displacement, that's a single swap. And double decomposition, a double swap. If you can remember these 4 patterns, you've got a handle on a huge chunk of all chemical reactions out there.
But wait, there's one more piece to this puzzle. A really crucial one, actually, and that's energy. You see, absolutely nothing happens in chemistry without some kind of energy being exchanged.
And when we talk about energy, reactions basically come in 2 main flavors. First, you have exothermic reactions. These are the ones that release energy, usually as heat and light. Think of a campfire. It's giving off warmth, right? That's exothermic. Then you have endothermic reactions, which do the opposite. They absorb heat from their surroundings. That's why those instant cold packs feel so cold to the touch. They're literally sucking the heat out of your skin.
Okay, so we know how to spot reactions, we know the main patterns they follow, and we know they all involve energy. So what's the last piece of the puzzle? Well, what actually makes them happen in the first place?
Yeah, reactions don't just happen for no reason. They need a trigger. Sometimes just mixing 2 things together is enough, but often they need a little push. That push could be heat, light, electricity, or even pressure. And sometimes you need a special helper, called a catalyst, which is a substance that kicks off a reaction or helps it go faster without getting used up itself.
All right, time for a super quick recap of the big ideas. Number 1, reactions are all about atoms rearranging themselves to make new stuff. Number 2, you can be a chemical detective by looking for the signs, a color change, bubbling gas, or a solid appearing out of nowhere. Number 3, most reactions follow one of those 4 main patterns, our chemical plays. And last but not least, every single reaction involves energy, either releasing it or absorbing it.
So I'll leave you with this final thought. Chemistry isn't just something that happens in a lab with beakers and funny-smelling liquids. It's happening right now. It's the rust on a bicycle. It's an apple turning brown. It's the cake you bake in the oven. So now that you know the rules of the game, I'm curious, what chemical reaction will you notice next?